I've been in love with databases since I discovered them in college. I love the elegance and beauty of databases of all types in theory and in practice. Many of you know me as a MySQL community member, as a MySQL consultant. Some of you know that I lurk at PostgreSQL conferences and write CouchDB white papers and review books on MongoDB and forecast the performance and scalability of VoltDB. Today I'm stepping out of my role as a MySQL consultant and Percona person to speak generally, to speak about all open source databases to the extent that I can. I love free software. I love free software databases in particular, and that's where my passion is, and that's what I want to talk about today. Software and systems do not exist in a vacuum. I'd like to talk for a few minutes about the context within which I think we should consider open source databases in order to understand them more fully. First of all, there's the data itself. In a world where data volumes are expanding beyond what we could imagine a few years ago, where fortunes are won and lost based on who owns or loses data, or who can turn data into real knowledge or fail to do so, data has become one of the central computing challenges of our generation. It's a relatively new phenomenon for human history to have to think about this on a large scale. We open source developers need to solve this challenge or watch others do it instead. Databases are not deployed and used today in the same ways that they were when I started working with them. Three key technological changes have occurred in this short time. The first is the rise of so-called NoSQL databases. This arguably first crept into the popular consciousness with Memcached. Today we have a number of popular technologies, most notably key-value data stores and document-oriented databases. NoSQL databases came into being for two main reasons. One is the so-called impedance mismatch between the worldview of a developer and the worldview of a relational database. The relational database model is difficult for developers because they're used to thinking in data structures and algorithms by and large. I think we've all got our horror stories about what happens when somebody has a hard time bridging the gap. The second main reason for NoSQL databases is a perceived or real performance problem. This is often called a scalability problem, but that's usually a misnomer. It's really just the poor performance of a particular relational implementation that's to blame. Many people remain convinced that the SQL and the relational data models are unscalable themselves inherently somehow. I think this is going to be proved wrong in the future, and I'll touch on that a little bit more in a few minutes. The second technological change that we're seeing is solid-state storage. Databases have been optimized for spinning disks for decades. There are very different access times for random and sequential access on disks with moving parts. When you hold the disk head in one place and just spin the spindle under it, you can get extremely high read speeds. When you're seeking all over the disk, it's a very different story. So by and large, today's databases are at least optimized or built with spinning disks in mind. With the arrival of solid-state storage, all of that changes. By and large, today's databases are not ready for them. The relational model itself, on the other hand, will benefit greatly from the lack of discrimination against random reads. Solid-state storage is still comparatively young, and there's a lot that we don't know yet. The landscape is changing rapidly. However, the trend is clear. Solid-state drives are getting bigger, faster, cheaper, and more reliable. In the future, we will almost certainly see solid-state storage morph into something approaching durable memory, very close to the CPU with very high bandwidth. PCIe drives are already much faster than SSD drives, but that's not the end of the story. The third paradigm shift is cloud computing. Although cloud computing may be at the apex of the hype cycle right now, and although it may cool off a bit in the next few years, or maybe not, I think there is something of lasting value behind it, and we're only beginning to see what's going to emerge. We'll see this after the signal-to-noise ratio improves a little bit. I'm rather conservative in my own approach to cloud computing. I see a few use cases where it's really beneficial, and I encourage people to use it there. Those would be specifically the ability to buy computing capacity as you need it and to throw it away when you're done with it. Many of our customers find, for example, that this lets them experiment with things that they couldn't otherwise experiment with because the capital expenses would be too high. So they can try, for example, a whole bunch of different types of games, and if some of them don't become popular, they just shut the servers down and they're done. The other thing is the economy of scale that's created by sharing some computing resources and outsourcing some infrastructure costs. So we have these three major technological changes: cloud computing, solid-state storage, and NoSQL access, that have created a very different context for open source databases in general today. How do open source databases fit into this context? From a technical standpoint, I think we're behind the curve. By and large, the software that we produce is not optimized for solid-state storage. It is not ready for deployment and distribution in the cloud. We're not really deploying and distributing databases the way that the cloud paradigms enable, and there will be new paradigms in the future that we're not aware of yet. And we don't really know how to think about NoSQL databases as a group. Now, I'm not saying that particular technologies aren't ready for, particular databases aren't ready for cloud or NoSQL or SSDs, or that particular individuals don't have well thought out understanding of these technologies. But as a group, I think we're not there yet. From a social standpoint, open source databases and the communities and businesses surrounding them face some troubling challenges. And these are not entirely outside external. Some of them are our own causing. The entropy that's created by all of this change is a fertile ground for new ideas, and there are a lot of brilliant minds at work trying out new theories, creating new technologies, trying novel approaches. At the same time, there is a lot of existing prior art that we're reinventing that we don't necessarily have to reinvent. Much of this comes from academia. Some of it comes from what I would call field experience from companies such as Google, who famously publish papers such as Bigtable and MapReduce papers. It also comes from people who just know what they're doing. They've built enough systems that they know what works. I think that we could benefit a lot more from this expertise and wisdom. The biggest challenge that I see is rivalry between our projects, between open source database projects. It's good to have some spirited competition. Competition creates an incentive, makes things fun. A little bit of competition goes a long way. It's fun to win. But we need to give a warm welcome to our colleagues from other open source databases. I give Brian Aker and Colin Charles a lot of credit for ensuring that there's a diversity of databases represented here today. I believe that as a group still, we've lost perspective and we continue to lack a little bit of perspective on how inadequate all of our solutions really are. Let me try and explain where I think we should set our targets, and then maybe that will be a little bit more clear. Today, we build big databases such as those that you read about on highscalability.com by sharding. Typically, these things are built on databases such as MySQL. What does it mean to shard a database to build a really large data store? It means that you hire a smart team of developers, and you spend a lot of money and a lot of time, and you experience a lot of pain and frustration, and you eventually hand-roll your own distributed database. And if you don't get it right, then you suffer. And it's really difficult to get this right, and it's really hard to find people who know how to get it right. So there's typically a lot of pain and suffering that goes on here. The result is also usually pretty low class when you compare it to the ideal distributed database. Think about tasks such as running an alter table across a sharded data store that has hundreds of servers. That's really miserable. Think about doing a consistent cluster-wide backup, or restores, or adding or removing nodes from that cluster. That's really pretty bad compared to what we would like our ideal database to be. So what about mid-sized databases? That's what things look like for really large databases. For moderately big databases, a few years ago, the answer was pretty much the same. You had to shard. Today, it's not quite so simple. A lot of today's software is significantly more scalable and more able to take advantage of big iron hardware. So a lot of databases can fit on a single machine and don't have to be sharded. Also, hardware, of course, has gotten much more powerful. So scaling out isn't the only option anymore. Scaling up is viable for a lot of servers. But still, the data is growing really fast, and although hardware has gotten more powerful and software has become more able to take advantage of it, two things remain true. Software isn't keeping up with hardware, and hardware is not keeping up with data. And it probably never will. Therefore, the world needs distributed databases, plain and simple. Scaling out will always be needed, and the database software itself needs to support this natively. It's very regrettable that we still have to do all that heavy lifting in application code. What about the cloud, where scaling out is the only option? That might be the only option now, but wait a few years and consider this. Is it plausible that in a little while you'll be able to buy really high-performance, big iron servers in the cloud? I think it's not only plausible, but it's inevitable. There's a few reasons for that. Databases do not run well with slow and unpredictable single-node performance. They also, distributed transactional systems don't run well with slow and unpredictable internode latencies. Okay? So some cloud computing providers keep trying to convince us that the only way to build our applications is to build on lots and lots and lots of low-power, unreliable, unpredictable, inconsistent machines. But other cloud providers actually get it, that that databases are different. You know, that may be okay for web servers, but it's not okay for database servers. Scalability is a precise mathematical equation, not some amorphous, fuzzy thing that we can just kind of throw around. There are coefficients in that equation, and when you throw these unpredictable and high latency and weird performance things into it, the coefficients of those factors then in that equation go up, and the resulting scalability curve takes a sharp dive. So we don't want 1 million servers pulled out of the distant past. We don't want it in the data center. We don't want it in the cloud. We don't want it on a train. We don't want it in a car. Not in a tree. Let me be, Sam. Let me be. Therefore, scaling up can't go out of fashion. We're still going to need cloud computing to support scaling up scenarios. So again, we haven't seen the end of the story with cloud computing. And cloud computing platforms of the future will look very different than they do today. We need scale both. Okay? Which open source database can scale smoothly today to tens of terabytes on commodity hardware with a highly transactional workload? How about petabytes? We're going to be drowning in petabyte scale databases before we know it. And these databases will be distributed, again, because hardware is not going to be able to keep up, period. And they will need to evolve after they are built. We will need to run alter table, whatever that looks like in the database of the future. You know, we're not always going to be able to do a big design up front. So we'll need the ability to back up and restore the database, add nodes, replace failed nodes, and so on. No open source database today can currently do all of that. We talk a lot about the need to build scale-out architecture or to create software that can scale up. Those are not orthogonal. We need software that can scale up on individual machines. It needs to be capable of also scaling out on multiple machines. And furthermore, it needs to be able to simultaneously scale out on multiple machines and up on individual machines. At the same time, we need to increase dramatically the performance and efficiency of database software so that we get more performance from the same hardware. I think that individual projects are making progress towards some of these goals, but we spend a lot of time comparing them against each other. I think we have tunnel vision. We're arguing over whether it's better to drive a Ford or a Chevy, and we've lost sight of how big the problem really is. This is what we need. The demands that will be placed on databases in the future are enormous, and frankly, the databases that we have today are not capable of serving the systems that I was building in 2006, much less 2016. I'm not saying that we're doing a bad job, I'm just saying that we're falling far short of what we really need. Let's look at this from another angle, which I don't think is discussed often enough. After building an application on any given database, most companies are not enthusiastic about migrating to a different platform whose capabilities are within the same order of magnitude. If they're going to switch, the pain has to be absolutely unbearable, or the benefit has to be huge, or both. The Chevy might have a few more cubic feet of legroom than the Ford, or the Ford might have another cup holder or two, but we're still talking about the same order of magnitude, and they're functionally equivalent. One of the big benefits that can drive a switch is the cost of running the database. This is also the hardest to quantify. Support and licensing costs are easy to quantify, but that's just a small part of the full equation. Sometimes people migrate to an open source database because it's cheaper. There are exceptions, but as a rule, people don't migrate to open source databases because they offer a richer set of features or better management tools or a more integrated development experience. Open source databases are not as good as proprietary databases by these metrics. Among the themes that I see in open source databases is whether we're good enough to lure someone off of a proprietary database. Database X is the Oracle killer. Database Y is almost as good as SQL Server, or not as good as SQL Server, but it's just as good for the subset of features, and they're not really using all of SQL Server's features anyway, right? Why are we doing this? Why are we settling for downgrading someone from a more powerful piece of software to a less powerful piece of software? A downgrade is a downgrade, limitations are limitations. We need to be aiming ourselves at the features and capabilities, and specifically these things that I mentioned earlier, that the proprietary databases have evolved to provide. We need to offer an upgrade or a horizontal move, not just a downgrade. We talk about proprietary vendor lock-in, but in many cases the reality is anyone who uses any platform, even an open source one, ends up being locked in to some extent. Switching is just something you can't contemplate after a while. The growth in future adoption of open source databases is in new deployments, not in convincing people to migrate. Migrations shuffle things from one place to another at best. They don't create new markets. If we're to create market share for open source in the future, we need to create a database that companies can seriously consider as their first choice for the database that they're going to build their new application on. Is this a fantasy? I don't think so. Consider the web browser market. Name me a proprietary closed source web browser that is orders of magnitude better than the open source ones. It's not there. The open source web browsers are on par with or better than the proprietary web browsers. It should be our goal to similarly take open source databases in a head-to-head competition with the proprietary databases. I'm sure that the market will have what the market needs with or without open source databases. In fact, there are a couple of proprietary databases that appear to be making the types of advances that I'm sure are needed. I'll mention just one of them, and that's Clustrix. There are many others, and Clustrix is new to the market, so it's premature to say that Clustrix is successful, but it appears that they're starting to solve some of these problems. Companies have big, expensive problems to solve, and if they have to spend a lot of money to do that, they will. Entrepreneurs and investors know this, and they're lining up and getting ready to do this. If we spend our time arguing over whether open source database X is as good as open source database Y in some little, in the big scheme of things, little feature or capability, we're just going to have to accept the consequences. And I think the natural outcome of that is that we're going to be left in the dust. I want to make another observation about the future of the database. I believe that it will be relational. It will support a wide variety of types of access, but the underlying model will be relational. Relational databases are simply too powerful to go away. They offer more features and more functionality and richer access to data than many of the alternatives. And at the same time, many of the alternatives can be built on top of them. I think that the performance problems with existing relational implementations will be solved and are being solved. I also think that a lot of these phrases like impedance mismatch are going to go away as we start to understand things better, as we start to understand the mathematical underpinnings of different types of data access. I think eventually we will realize that there is no impedance mismatch with relational technology. MySQL used to be the default database for web applications, and I see a lot of people reconsidering that today, especially depending on the audience that you talk to, such as Ruby on Rails developers. I don't know which open source databases will be popular in the future, but I can make some observations. First, Drizzle and PostgreSQL are making long-term investments in the future developability of their code bases. If you've not read their source code, I encourage you to try it. It really is, as Bruce Momgen said the other day, a joy to work with. The open source databases that succeed in the future will do so because their code base enables the long-term sustained effort that's going to take to get us from here to there. A database with a brittle and ugly code base is going to end up painting itself into a corner or requiring massive investments that are infeasible to develop new features and capabilities. I like that Drizzle is a microkernel design with plugins. I should also mention InnoDB, which is like a Mercedes that just keeps going. I can't think of many other pieces of code that have remained fundamentally the same in their architecture and have beautiful code the way that InnoDB does, while the world changes around them. InnoDB is elegant and clean and is likely to live a long and productive life. I got ahead of myself. I'm going to go back. And ahead yet. I want to address a prediction I've heard, which is that the data center of the future will be a set of diverse technologies coexisting beside each other. Relational databases living next to document-oriented databases, talking to key-value data stores. I want you to put yourself in the shoes of a CTO of a large company and think about what this would mean to you. If your architect came to you and said, I think that we need to build on PostgreSQL and CouchDB, and we need React as well, and we need to glue all of these things together, what would you say? If I were that CTO, I would say, over my dead body. It's just a nightmare. You know, the idea that we're going to build systems like this that won't be cost and complexity nightmare is a fairy tale. So smart architects use diverse technologies when they're forced to, not because they think it's cool or because they think it's a good idea. And again, the database of the future will support a diversity of access types. So if we continue building technologies that do only one of these things, we should prepare for them to be obsoleted. I want to focus briefly on another thing that has changed in the last few years of open source database history. This is MySQL's acquisition, and it matters to all open source databases because MySQL is the largest, most popular, and most commercially successful database. So a lot of eyes have been on MySQL. I think that we as a community could have reacted better to Oracle purchasing Sun, who had purchased MySQL. The shockwaves that got sent through the entire open source database community have not been very pleasant. As part of my preparation for this talk, I watched Edward Screven's keynote from last year again. I was here in that audience. And like many of you in the audience in 2010, I felt a lot of uncertainty. I didn't know what to think. But when I watched the video recording again, I was struck by how straightforward he really was. He was direct and to the point. Oracle wants to make money from MySQL. They want to make it a commercial success. And they realize that to do that, they need to make it a community success, that they need to drive wide adoption, and that they need to make it flourish. But broadly speaking, we didn't believe when Edward said that. And I think we've been too skeptical. I can't count the number of times that I've been approached by people at conferences or emailed or talked with people in general. And they've asked me whether Oracle was sabotaging or neglecting MySQL. I see no reason to believe that that has been happening. I see no reason to be suspicious. I see instead that they're executing on the plans that they laid out last year in Mr. Screven's keynote. I see MySQL 5.5, which I believe might be the highest quality MySQL release in history. There has been no flood of bugs discovered after the release, which has happened in all of the previous releases that I've seen. I see MySQL 5.6 announcements this week showing that the MySQL development is far from neglected or stalled. I see continuing investment in improving InterDB and really dramatic changes and improvements to MySQL cluster. But most of this good news has been lost in the additional entropy generated by fear and uncertainty over what Oracle could do. I took a wait-and-see approach initially as well. I think Oracle has provided plenty of evidence for us to relax that a little bit and give them a little more benefit of the doubt. I think that they're following their stated goals of investing heavily in MySQL and making it a technical and commercial success. I also see that they're really trying to learn how to engage with the open source community. And I think we could cut them a break on that and give them a hand where possible. I pointed out to a commenter on my blog recently, just because the documentation search on MySQL is broken doesn't mean a blanket policy of corporate evil. It just means the documentation search is broken. That's all. We shouldn't read into that. Nobody asked me to defend Oracle. I'm doing this because I think that the continued sniping against Oracle is really destructive to the whole open source database movement, and I'm also, frankly, just sick of the negativity. If I thought Oracle was bad for MySQL, those of you who know me, you know that I would tell you in no uncertain terms. There's enough real threats to open source databases that we don't need to invent or imagine new ones. So back to my key points. The data is coming. The market will provide solutions. Open sources of the databases of the future need to be good, not just better than we are right now. This is hard. If we wanted to achieve this, if we want to find a rival to outdo, we need to look to the commercial open source databases because they're damn good. They really are. I don't want us to be picking over the carcass while the lions are making the next kill. I want us to stop being negative about Oracle. I want us to stop being negative about each other and focus on what we can achieve. I want us to aim our sights and invest our energy there. Of course, no database, open source or closed source, that exists today has really solved all of the problems that need solving. If it had, we would all be using it today. So just to recap, I think we need databases that can expand and shrink dynamically, that can self-heal, that can cluster seamlessly, that can perform non-blocking changes such as schema and indexing, that can support a diversity of access methods, that can be backed up and restored cluster-wide, and so on. How do we achieve that? I believe that we have the technical ability to do that. We need money, of course, and there is significant investment in open source databases from all sorts of companies. So although it's a daunting task, I think it's achievable. Another vital ingredient is leadership from companies and individuals. I believe that effective leadership is earned, not claimed. You don't just show up and say, I am the future of open source databases. That's not the way it works. There's plenty of competition and politics in open source, just like anywhere else, but one of the key differences between our communities and, say, a company that runs an all-Microsoft technology stack is this open source culture. I can't really describe that culture to you today in this address, but I know because I've lived in both worlds. I came from an all-Microsoft shop several years ago. I know that one of the attributes of open source culture is that anything that I say about it is something that you can disagree with and you'll be right. Leadership doesn't have to be altruistic. A company can be a technical or market leader in the field and lead by example. There is no reason that this company can't make a lot of money from this. Making money is a virtuous thing to do. One final thing we need, and we have it in our hands right now, but we could so easily let it slip away if we're not careful. We need a forum to continue to exchange our thoughts and our ideas, to build on our strengths and learn from our differences. We need, in fact, the O'Reilly MySQL and Beyond Conference and Expo. We need O'Reilly to continue to support this event in the future. This very conference sustains a large portion of the open source database community. This is something truly unique. It's the intersection of commercialism and open source and databases. There's tremendous opportunity here. You don't find this at any other conference. No other conference is so uniquely effective in advancing our shared goals. We need to ensure that O'Reilly continues to profit from this event in years to come. We need to come, we need to speak, and we especially need to sponsor an exhibit. We especially need Oracle to support this event. Oracle, you said that you want to help the MySQL community flourish so that you can make it a commercial success. For MySQL to thrive, we need your involvement in this conference. The writing is on the wall. MySQL can be a curiosity at Oracle events, but it can never be a main attraction. The Oracle and MySQL user communities are simply too different. Please promise O'Reilly that you'll continue to support this event next year and beyond. And so I want to end with thanks. I want to thank you for coming here and supporting this event, for meeting with friends, for making new friends. Thank you for sponsoring and exhibiting. Thank you for traveling across the globe to be here, from Israel, from Japan, from Australia. And finally, a huge thank you to O'Reilly's conference staff. The more conferences I sponsor and speak at and help organize and otherwise get involved with, the more impressed I am with O'Reilly's conferences staff. They run a world-class operation. They really get the open source mindset, and they're just a joy to work with on every level. So thank you, O'Reilly, and please do this again.